Welcome to this video on constructing redox equations. This time we're going to look at neutral and alkaline conditions. So how do the methods differ when you're doing that? And the answer is that they don't differ very much, but there is some very important considerations that we need to make, and so that's what we're going to look at here. So I'm going to give you just a little exercise to begin with, is that I've got this reaction here and it takes place in the alkaline conditions. I want you to pause the video and try and see if you can balance it. Well, how did you get on? Perhaps you thought, well, if it's alkaline conditions, I'm going to need some OH minus on the left, and then I'm probably going to need, if I've got hydrogen on the right, I can't use H plus, I'm going to have to use water. So these are the species that are going to appear in the equation. But it's very, very difficult to balance this because we've got on the left-hand side two different species containing oxygen and hydrogen. On the right, we've got two species with oxygen and one with hydrogen. So it's going to be pretty tricky to get these balancing numbers correct, and you can see at the end of the video just how difficult that's going to be when you look at the final balancing numbers. So we need some sort of trick in order to try to help us. So here's the strategy that I'm suggesting that we adopt. I'm indebted to ChemGuide for pointing this out to me. So we're going to first start off writing any equations as if we're in acidic conditions. So we're going to use H plus and H2O as our two extra species for balancing. And we're then going to, in a second step, convert to alkaline conditions by adding OH minus ions to both sides of the equations in order to neutralize any H plus that is present. It's important to realize that the number 2 is essentially a trick. It's not saying that this reaction would really happen. It's just saying that it's just a trick that helps us to get the right answer. And the reason we write half equations in acidic conditions is that when we've got just H plus to use to balance, we can always balance the hydrogens independently of the oxygens, which simplifies the problem. Now at the bottom here I've just put that this works when you're balancing half equations, and it also works for full equations, whether you got them from oxidation number balancing or from combining half equations. You can do this trick number 2, at any point in the process. Now in the subsequent steps I'm going to do it for half equations, and that's purely there just to give you a bit more practice. So here we go. Step number 1, can we write the half equations in acidic conditions? So pause the video, try and see how you manage to get on with this. Okay, here are the answers that you should have got: oxidation and reduction. Check yours, see whether you got them right. Let's move on to how we could convert these then into alkaline conditions. So what I'm going to do is recognize here that I've got 8 H plus ions on the right hand side, so I'm going to add 8 OH minus ions over on the right hand side. Now because it's an equation just like a mathematical equation, if I add 8 OH minus to the right, I've got to add 8 OH minus on the left hand side as well. Now where does that actually leave me? Well, if I rewrite it again underneath, I've got 8 OH minus and Cr3 plus and 4 H2O. Again forms 3 electrons. The chromate stays as it is, but 8H plus and 8 OH minus will become 8 H2O. So I've got a neutralization reaction happening here between these species. Let's see what happens in the reduction half equation. Well, in this case I've got 2 H pluses here, so I need 2 OH minus in order to neutralize them, and that's going to give me 2 H2O in the final equation. And that means I've got to have 2 OH minus over here. So if I just copy down what I would be getting, just make that plus a bit bigger, I've got this. So again I'll just highlight what happened over here with these two guys here that got neutralized. Now what you should notice as we're doing this is that, remember, what we have to do at the end of the half equation is just to cancel any species that are the same on both sides. And we can see here we've got 4 H2Os and 8 H2O, so we need to get rid of the 4, and we actually only produce 4 H2O as a product. And similarly here we've actually got 2 H2Os on both sides, so they're both going to cancel. Okay, so those are the two half equations now under alkaline conditions. We need to then have a go at trying to combine them, so it'd be good if you pause the video and just see if you can combine those half equations using the same techniques. So there's oxidation, reduction, and this is what you should have got. And you can see from that final equation just how horrible the balancing numbers are. That's going to have taken you an awfully long time in order to balance that with another technique. So the advantage of this technique is that it allows you to just step through the problem gradually, with no one step being particularly challenging, which particularly under exam conditions is quite useful. Not necessarily the fastest method, but it will get you reliably to the correct answer. So in summary, when you're in alkaline conditions, you must use OH minus along with H2O to balance atoms. You can't use H plus because concentrations of H plus in alkaline conditions are far too low. But in order to actually do that, then you're going to have two steps. The first is to write equations as if I'm in acid using H plus. And then in a second step, we're going to convert to alkaline conditions by adding OH minus ions to both sides. Now, what about neutral conditions? Well, in those cases, we haven't really got a particularly high concentration of OH minus or H plus, but they could be the products of the reaction, so we can't use them as reactants. We can only have them as products. So my suggestion is, because it's easier, you start balancing using H plus, and if you find H plus is a product, then it's fine. But if you find that H plus is a reactant, then fundamentally what's going to happen is that you just simply need to neutralize your H pluses with OH minus, and you'll reveal a reaction where OH minus is the product. And if I just flick you back to an earlier stage in the video, you can actually see how that's coming out. So if we look at this case here where H plus is a product, that translates into an equation where OH minus is a reactant. Whereas if you look at a reaction where H plus is a reactant, when you've turned to alkaline conditions, it would actually mean that OH minus is a product. So this bottom reaction here could be a reaction that takes place under neutral conditions. The top one here would have to be alkaline conditions. So that's how you construct redox equations under neutral and alkaline conditions.